All right, let me make this a little bit bigger. Hello, hello. Let me set my timer. Look, they're about to make the call.
The learning commons will be closing in 30 minutes.
Yep,
Study routines are due in 15 minutes.
yep. All of the above. This is just the easiest place I like making my videos so far, you know? I don't have really good office space at home yet. So, I'll come up here. Girl, be quiet.
The learning commons will be closing in 30 minutes.
30 minutes, y'all. Y'all hear that? All right, so that means I have less than 30 minutes to break down. Today, I was going to do complex numbers. All right, you know what complex numbers are? Complex numbers. What are complex numbers? What have you learned that they are so far? For me, I know that automatically includes this imaginary I, right? And of course, I stands for imaginary. I hope you all are caught up on this. I know that I'm skipping around a little bit on concepts, but I'm trying to meet the request that's being given to me. So, a lot of you are in college algebra this semester. You're working on complex numbers, basically imaginary numbers, right? So we know the story, correct? Hopefully we know the story. If not, let's talk about the story real briefly because you know I only have 30 minutes. So somewhere along the lines, you guys, you did radicals, you did roots, and all this, and you learned some cool stuff. You learned that the opposite of squaring something is taking the square root of it. You learned that when you write, you learned hopefully that the square root of x can be rewritten as x to the first power because you know this is the index and everything always understood to have a 1 outside of it. Some of you parentheses, some of you don't. Some of you parentheses here. At this time, I don't think it's at this level, depending on what level of math. If you're in college algebra or below, be attentive to where your parentheses are, right? Because I know I've seen it taught this way, although I can't say that I agree with that. I can 1000% agree with this, right? 1000% agree with this. I don't know if that's, in this case, it's accurate, but if that x had a different exponent, it wouldn't be the case, right? So anyway, so I know you've gone over, or hopefully you've gone over things.
Complete. The learning commons will be closing in 30 minutes at 5 p.m. All study routines must be turned in 15 minutes at 4:45 p.m. Computers will also shut down in 15 minutes.
I'm just waiting for that. I can't talk over that, right? Okay, so yeah, this 1000% accurate, but it depends on the instructor and how they lay that information out for you. So we're gonna build off of this situation, right? Because the square root of x can be rewritten as x to the 1/2 power. Well, let's talk about other forms of rewriting, right? We also have this little fancy thing here. We have that x squared, the value of x squared is equal to -1. You're like, what? Now there's a whole law and a whole reasoning and all these rules behind it. Does my 1 look like a 1 to y'all? Hopefully it looks like a 1 on camera. You know, sometimes you change your writing. I'm making my 1s different. I don't know why. I just feel like that's better. But now I need to make the negative. So nonetheless, the value of x squared is equal to -1. So -1, we're going to rewrite x and make it I squared, right? And I squared is equal, wait a minute. Oh, yeah. I'm not gonna, it's 1, but we'll talk about that, okay? I was gonna go over the long story of how it came, but I only have 30 minutes, and I know you guys kind of, if you want to hear the backstory, you'll put it in the comments, right? You'll put the backstory in there. I need to know why, right? You need to know why. But let me say this, if I squared is equal to 1, then what do you think just I is? What do you think I is? What would I be? Just going off of that right there. What do you think? So to get I, right here, I squared is positive 1. I, then, is going to be the value of the square root of negative 1. You're like, wait, what? Yes. I is the value of the square root of negative 1. So anytime you have the square root of a negative value, because you know, so check it out, laws and rules say this. Anything squared means it's a value times itself, correct? So if we say we have 2 squared, that means we have 2 times 2. And the value of that is 4. Even if we said we had negative 2 squared, that still means negative 2 times negative 2. And we know the rules of negative integers say that a negative times a negative is a positive. Okay? So now my purple's dying. Let's take, if we had negative 4 squared. Right? So again, rules never, ever, ever change. So that's going to be negative 4 times negative 4. And a negative times a negative is a positive. Right? If you had negative 3w squared. So again, you recognize this, the 2, we call that an exponent if you haven't already gone over that. Another word for the 2, because it is a 2, it is called squared. Squared and square roots opposite, okay? Cube and cube roots are opposite. But anyway, we're talking about squared. Squared means multiply times itself, whatever it is. If it's a negative value, that has to be included, right? So that's going to be negative 3w times negative 3w. Negative times negative is positive. 3 times 3 is 9. W times w, w squared. Right? All of that's cool. So then we come over here and we're like, okay, cool. So does that mean the square root of 9w squared, when we ask for the square root, it's what did we multiply times itself. And so this is the key thing about I, you have to remember. Because when you square it, it's times itself, be it negative times negative or positive times positive. They have to be the exact same, right? So what did I multiply? What same value did I multiply times itself to get that? Well, because we just did it, we know that this breaks down into the square root of 9 times w squared, which breaks down to 3 times 3 times w, right? And then when you're taking the square root, you're looking for a set of pairs, right? A set of pairs, like a pair of shoes. Remember I talked about this? A pair of shoes takes 2 pairs. You have to have 2 shoes to have 1 pair. So a pair means 2 values. I have 2 3s, so one of them will come out. And I have 2 w's, so one of them will come out. And as we know, it was 3w. However, we multiplied a negative times a negative, and we still got a positive 9, right? So we know a negative times a negative will give us a positive, and a positive times a positive will also give us a positive. So that means when we need the square root of certain values, we have to consider that. If we need the square root of positive 16, and we always know it's gonna be positive, right? That means we multiplied either 2 negatives or 2 positives. Yeah? We can't take the square root of a negative value. If it's, so like right here, we have the square root of 16. That means what do we multiply times itself, right? So the answer is technically either positive or negative 4. So a lot of you are doing that plus minus. That's why it's plus minus. Because we know if we had 2 negatives 4s, it would make positive 16, and 2 positive 4s also makes positive 16. So your answer is technically plus or minus. You have 2 answers when it comes to square root because you have a positive value and possibly a negative value. However, again, when we're talking about square roots, that means we multiplied something times itself. So right here, if we have the square root of negative 16. Now, can we do that? Since rules do not ever change, right? Math rules do not ever change. Again, in order to get this negative value, that means one of the factors I multiplied was either positive and one of the factors I multiplied was negative. That's the only way I can get a negative, right? 2 negatives make a positive and 2 positives makes a positive. So I can't have, if I have one, like these are not the same value. Right? We know they're not the same value. They're not in the same spot. On the number line, they have 2 completely, right? One's way over here on the left talking about I owe $4. One says I gained $4. Not the same value. They look like the same number, but they're not the same value. One is negative and one is positive. If I were to multiply these 2, I could get negative 16. But if I were to multiply these 2, then technically I'm not squaring it. To square it, it has to be exactly the same, right? There's no ring light on. My ring light's still working? There we go. Hopefully that helped. But when I square it, it has to be exactly the same. So either both my values are positive or both of my values are negative. Okay? So when we're dealing with this I, this imaginary, again, I's value is negative 1. So for this answer, what is the square root of negative 16? Well, the square root, now we're not going to say plus or minus 4 because we know it couldn't have been a positive 4. So that plus 4 don't count. That means we know that it was minus 4, kind of. That would be more likely. However, if it was 2 negative 4s we multiplied, then it would be positive. So this is where that I comes in. I represents imaginary. Imaginary starts with I. So my square root of negative 16 for I, imaginary. It's an imaginary value. That's where this I comes from. Okay? That's how we do this I. So again, let's see. If we had, I'm looking for a good example. So I don't like that example. I'm like, I don't like that example. But I do like how they break down I for you. So let me show you something. For all values of A that are greater than 0, that means for all positive values of A. For all positive values of A. So that means, like I said, that says A is greater than 0. Right? And if A is greater than 0, then that means you're on the right of the number line. That means it has to be all positive. So anytime you see this, it's not necessarily saying A is greater than 0. It does say A is greater than 0, but what the text, if you read this in a textbook or if your teacher writes this on the board, you need to know all values are positive. Okay? These are things that, like, if you stop and think about it, you're like, oh yeah, everything to the right of the 0 is positive. So yeah. But that's how you interpret math. That's what they want you to think, right? You want to think about all possible potential reasons that it could be. So let's take, as long as A is positive or greater than 0, then the square root of negative A is always going to have the value of I square root of A, right? So it's like you took this negative out, you pulled that negative out, and it became the I. Right? So you can't, let's just say you had the square root of negative 49. So you can't do anything with that yet, right? So say you try to break it down, then you would break it down maybe to negative 7 times 7. Well, again, you can't have that, right? For that to be negative 7, then it would be negative 1 times 7 times 7, right? This negative 1, it's under the square root, right? The square root of negative 1, that's under there, so it's gonna come out and it turns into an I. And now you know the square root of 49 is 7, right? So it would be 7I. I'm gonna do one more for you. So I know I kind of worked it backwards, but hopefully you can catch down with the video, right? I know I'm talking fast too. It's because I was like going back and forth trying to get all my stuff ready, trying to find what I was gonna go over, and I knew it was about to be closing time. My lunch was late today. It was just a late day. All right, so let me find one more. I thought I had a good one. Oh, here we go. Let's try this one. The square root of negative 48. We're going to do one that's not like an even square root, right? An even root. So when you first look at 48, of course, you're supposed to think to yourself, do I have a perfect square for 48? I know I have 1 times 48. I have 2 times 24. 3 times 16. Ooh, that might work. 4 times 12. And 6 times 8, right? So you'll find I'm always listing factors. Listing factors is just going to help you be so good. It's definitely going to strengthen your multiplication. Since multiplication is the opposite of division, it's going to strengthen your division as well. It's going to help you get a lot faster the more you practice this. And it takes a ton of practice. But I know I'm working with radicals, which are square roots. So I need to find a set of factors that has a perfect square. All of them won't, but sometimes you luck out. Ooh, looky there, 3 and 16. So that means I'm going to take this and I'm going to say, well, I could have multiplied negative 3 times 16, right? And then I know that I can't really have a negative 3, so that was negative 1 times 3 times 16. And I remember that just because I wrote it like this, that means I probably started with this. Right? The square root of negative 1 times the square root of 3 times the square root of 16. Well, this we know has a perfect root, which is 4. This can't be, it doesn't have a perfect root, so we leave it under the radical. This becomes an I, so our answer, right? 4I square root of 3. Is that starting to click a little bit? Especially if you break it down like that? Let me see. Let me get you one, let me get you a fraction one or something, right? Let's see, let's do this. I'll get you a fraction one. Okay. And then I'm going to tell you something really cool. My favorite thing about I's. And I think I told somebody this already. You already know it. If I work with you this week in person, then you already know my favorite thing about I's. But let's do one more. Let's do one more simplifying, right? We're going to take, I had a really good one over here somewhere. Oh, there it is. So say we have negative square root. Oh, that's the feature time. Square root of negative 48 over, that's a good one, the square root of 24. So again, I chose this one because it's got some good stuff that you kind of have to remember, you know, just like breaking this down. So you should remember that this can also be rewritten as this, right? That means it probably started like this, and then they broke it down.
Your attention, please. The learning commons will be closing in 10 minutes at 5 p.m.
And then they broke it down like this.
All work. And bring any materials we checked out to the circulation desk at this time.
So it started like this, broke it down like this, right? To make it easier, because now we have the square root of negative, oh, yay, we already have factors for 48. That's what's up. And I'm going to interrupt myself and make factors of 24 just because I like making factors. I'm just kidding. It's really helpful. Oh. Almost wrote 4, right? And I do it like this too, remember, because 1, 2, 3, 4, 6, 8, 12. I know I'm done. The only number that's missing is 5, and 5 is not a factor of 24. So, it started here, and we rewrite it like this. What do we do with that negative, right? Well, let's break it down. That means we have negative 1 times, what do we want to choose for 48? Times 3 times 16, right? And then 24, we can break it down as, did we have a nice set we wanted to use? Anything? See any perfect? Okay, 4 and 6, good. 4 times 6. Right? So then we break that down into the square root of negative 1. Oh no, 20 minutes is up. I got 5 minutes to show you this. The square root of 1 times the square root of 3 times the square root of 16 over the square root of 4 times the square root of 6. Right? We know this one breaks down, well, this is a 2, and we know this is a 4. This becomes what? The I, right. So our final answer, we still have this down here, well not final, but our reduced answer, we're going to have 4I root 3 over, so this 4 had a perfect root, right? That's going to be 2 and root 6. So, not like terms, but these on the outside, remember this implies multiplication. So if we can reduce this, we surely can, because that's 2 times the square root of 6 over 4 times I times the square root of 3. So we can reduce these two, right? And that leaves us with 2I root 3 over root 6. Oh, wait. You know what? Because if you leave it like this, root 6, can I do that? I think I can. I believe, now here we go. I worked it a little differently, right? I was on the same track, and I forgot when I did it like this, yes, you can divide. Yes, you can divide. So yes, you could have divided first. Yes. But when I did it like this, let's just say you forgot to divide like I did, because I forgot to divide. But guess what? The square root of 6 breaks down to the square root of 2 times the square root of 3, because they're both under the radical and they both can't be simplified. I know this is going to be weird for you. I was trying to decide if I should show you the long process, but I don't have a lot of time. Let's see. Because if I make that, and those would reduce out. No, just divide first. Just divide first. Look to see if you divide. I know. I hate when I do that. I hate when I get started on it and I'm going. But like I said, it's going to be a longer process. And we're about to close, as you heard. So unfortunately, I'm going to erase, well, you saw it there. But I'm going to erase it and I'm going to go to divide, okay? Just because it's so much easier. Because that is a long process, and I'm not saying you won't understand it, but it gets a little ugly because then you got to do this whole negative positive thing. Okay. So, I'm going to say if we divide first, that means you have the square root of negative 2, right? Because we can do that. And then, much easier, right? So, and you know what, technically, let me say this, and hopefully if you've been watching my videos, you called me out. You should have said, well, Nikki, shouldn't I divide first anyway? Because a radical is a grouping symbol, and that's order of operations. We do parentheses and all other grouping symbols first. And I would have been like, you know what? You so right. That's what happens. You start doing all this other math and you just forget the simple rules. And I'm not even trying to be funny, but that's literally how it goes. The more you advance in your math, you learn so many other things, so many other rules, you start to question old stuff. You're like, nah, it can't be, nah, it can't be. But in reality, you guys, yes, let me tell you this, yes. All through Calculus 3, I was like, nah, it can't be. Yes. And again, sometimes it's a longer process. However, no matter what the rule is, it has not changed, it will not change. You just have to slow down and read it right. Like I should have slowed down and read it right. If I was paying attention, I'd have been like, oh dang, you would have just divided. And then we pull out this negative right here, boom, because it is what? I root 2, right? So, practice what I say.
The comments are closing in 5 minutes.
5 minutes, okay. Okay, all right. 5 more minutes, 5 more minutes. Let me tell you one thing about I, okay? And I'll start over. This is the fun thing about I. There's only 4 values for I, right? It goes I to the first power, I to the second power. Look, you have I. So I tell everybody this. Act like you won the lottery. What do you say if you scratch off a ticket? I won! I won! Right? Right? I won! Okay. So I want you to do me a favor. I want you to write I won, I won. I won, but I won. Okay? Make the middle 2 values negative. And now you have your rules for I. Because every power of I, it repeats after the 4th power, right? So that's I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. This is I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, I to the 10th, I to the 11th, I to the 12th, and so forth, right? So yes, that means, I hope I have enough time. If you had I to the 1738, just made a number, I would take that number, I'm going to divide it by 4. Oh man. Oh wait, 4 goes into 18, what, 4 times, that's 16. All right, so my remainder is 2. That means I to the 1738 has the same value as I to the 2nd. And I to the 2nd is what? -1. So therefore, I to the 1738 is, oops, sorry, I was gonna put I, is -1. Right? So again, there's only 4 powers of I. You have I to the 1st power, I to the 2nd power, I to the 3rd power, and I to the 4th power. So if you write, I won, and make the middle 2 negative, kind of write something like this out, then you know whatever the exponent is, divide it by 4, and that remainder will tell you what power it is. It is either going to be 1, 2, 3, or 4. And you know if your remainder is 0, everything to the power of 0 is 1. Okay? If you have I to the 4th, that's like doubling I squared, right? So that means -1 times -1, right? Watch it over. I know it sounds confusing. I know I was talking fast. But I wanted to get a little bit of I up there for you while I had the chance. And I think my time's about up. So I'll see y'all next time later. Oh, sorry about that long path over there too. It happens sometimes. See you later.